All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we just finished up our malaria custom layers module. Let's have a look at what we went over today. Now, yesterday, if you recall, we started the process of actually compiling our code and running it. I did that overnight, so let's see what that actually came up with. Now, it's supposed to be, I think, 5 or 10 epics, but of course, I dropped it down to 1 epic just so we can get the training done and can have this example ready for you today. And as you can see, that's right down here. This is our epic here. So you can see here we train for 4 seconds per step for 2,970 seconds. We have a loss of 0.0186 with the accuracy of 0.9958. Then we have a validation loss of 4.859 with a validation accuracy of 100%. So yeah, everything's working fine with our custom layers. So everything did go smooth. And that was actually the last step in our custom layers module. We did start a new module today. We didn't do much in it. I just brought over all the information that we're going to need, all of the previous information. We did some light note taking. I guess we can do some light reading just to see exactly what we're going to be doing. So in this section, we'll be going over model precision, recall, and accuracy. Here we will be looking at models or other methods of evaluating our model other than the binary accuracy located inside the metrics, which we've seen so far. So in this section, we'll look at how to compare true positives, false positives, true negatives, false negatives, the precision, the recall, the area under the curve, how to come up with confusion metrics, and finally, this supposed to be in, sorry about that, and finally, how to plot out an ROC curve, which permits us to select the threshold more efficiently. Now, let's start by looking at other ways we can evaluate our model other than accuracy. To better understand why working with other accuracies isn't always a good idea, we have to take into consideration the fact that our model on a test set has 94% accuracy. It's supposed to be to better understand why working with other models isn't, well, why working with other accuracies isn't such a good idea. Sorry about that. Now, this means that we have a 6 out of 100 6 out of 100 predictions, which are actually false. So we got a 94% accuracy. That means 6 of our predictions are actually going to be false out of the 100. So now that if we get to the hospital and we're told that we don't have malaria, when in fact we do have the actual disease, that's going to be 6 out of 100 times that happens because we only have a 94% accuracy, which is kind of huge if you're dealing with a situation like that. Now, what if we get to the hospital and we're told that we don't have malaria when in fact we do have the actual disease? With that said, the model predicted uninfected, but we actually have the parasite in our bloodstream. This particular situation becomes very dangerous because the patient goes home thinking they don't need any treatment, whereas the patient actually has the parasite. When we see that with the 94% accuracy, we wouldn't be able to save ourselves from such a chaotic model prediction. In another example, we have a situation where the actual is unparasitized. So actually, we don't have the parasite, but the model predicts that we have the parasite. So it'll be the exact opposite of what I just said. So the prediction or the actual will be that we don't have the parasite, but the model will predict that we do have it. So we would go home worried when we don't actually have the parasite at all. In this case, although we have the wrong prediction, we actually have a less chaotic situation as compared to the previous case since we're actually uninfected. Like I just said, the first situation we were told we don't have it when we actually had it, but in the second situation we didn't have it, but we were told we did have it. So it'll be less chaotic for the second situation. The only thing where we lose is a little sleep at night, thinking that we're actually infected with malaria when we don't actually have it. We'll consider negative to be represented by U, which stands for unaffected, and we'll consider positive to be represented by P, which stands for parasitic. Now that's why I left it at so far. Like I said, this is a brand new module we just started, the malaria precision, recall, and accuracy module. So yeah, I'm gonna leave it there for now. We're gonna pick up fresh tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.